There we go. All right, and good morning. For those who are wondering what this is about, this is 3D printing for non-printers. My name is Daniel Mills, Lord Eledan of Berlagmark, Neverwinter. This is just a good morning. I can hear the echo, Kelly.
Whoops, sorry, I gotta mute myself.
There we go, thank you. Anyways, the whole point of this is I want to talk about just the basics of what 3D printing is, and kind of give an overview of what it is involved for actually getting into 3D printing, and then at the end talk about things to look for with AmpGuard in regards to a good 3D print. So that way we can start integrating this newer art form into our existing ANS structure. What is 3D printing? The basics of it is adding layers of material onto a product to make a larger, more complete product. This is typically controlled by a computer, but there are 3D printing items out there where you can do this manually. The example would be a 3D pen, which is basically a non-motorized version of what I will be showing in a moment as a filament printer. For computer-controlled 3D printing, you typically go through a slicer program for actually breaking the thing into manageable layers for the thing, and I will show an example of that in a few moments. As a whole, there are two main types of 3D printing mediums. The first would be the fusion deposit model, which is filament printing. You're taking a layer of material and just continuously melting it onto the prior layers, and that's how you build it up. Typically, this is handled bottom to top, right, and then with all the prints right side up. It is also the simplest and most common medium of use. Because when you're dealing with this, you're dealing with just plastic, and all you have to do is manage the temperatures. The only post-processing cleanup that you have to do before you go on to any other common things is just de-stringing it. I'll talk about all these things in a little bit more detail as for when I do my live share parts of things. Right now, I'm just trying to introduce everything. The other medium would be your resin printers. This is where this is using a UV. Think of it like a TV, but it's all UV based. The finer the resolution on the screen, the finer detail you can put into what you're printing. But anyways, your resin is held in a clear bottom tub, light shines through it, and then the plate lifts up as it builds up. Your prints get built upside down. But it's because you're dealing with UV light, it's actually you actually get a much finer resolution on everything. Anyways, just to show you about what I'm talking about for some of these things, but looking at the hardware of a printer, basic materials, and then just a few tools of the trade. I'm going to stop the screen share. And Kelly, is my screen full? Is my video full screen? Me, my face?
I should pin you. You are.
Thank you. Just want to make.
Sure.
Just want to make sure.
Yeah.
Nice. Okay. So, anyways, looking at things, first thing I'm going to show off. So this is a little bit overkill for what you need for getting into it. I'm hand doing a from a webcam, so sorry if I'm a little bit shaky. Perks and pains of being live. this is my filament printer. This is a Creality Ender 3. There's like 20 different brands and everything like that. Yes, I have it printing. The concept is that right here, I have a filament dryer box. So that way my material, when I get into materials that are a little bit more moisture sensitive, I can keep them dry while printing. The machine pulls it in with there's a motor right under where that blue knob is. And then inside the black box there is where the hot end is that melts the filament as it comes out. And obviously there's motors that control the X, Y, and Z axis movements. And the slicer, for what that does is it will actually go and rotate. You can see it's going at a diagonal. At the next layer, it will be going diagonal in the opposite direction. So that way it will actually be fully supported on the inside. The plate that's printing on itself is heated also, which helps reduce warping, which is also a much more critical thing for when you get into more temperature sensitive processes. The print chain is just me having fun with the printer, which is part of the perk of getting into printing is you build your own setup beyond your baseline hardware. You can get as complex, integrated, or fun as you want. Like, for example, I can't really show it off right now because I need to rebuild the image on it, but I bought a Raspberry Pi that I've plugged into it for controlling the printer over Wi-Fi. Something that's not shown, that I barely showed a little bit because it's just black box from here, is I bought an air purifier, so that way when I do get into materials like ABS plastic, TPU, nylon, those things which put out fumes when you're printing, I can just turn that on and leave it on for the duration of the print, and I won't smell the room. This room is also my home office. Flipping around, this is a resin printer. There we are. Like I've said in the thing, this part up here is what moves up and down. You have a clear bottom tub that you put your resin into, and there's a UV light that shines up through it to go and print your things. And then the shell of it has a UV resistant coated for outside of it. The other thing with UV printers, as I get stuck on my floor there, the other thing about UV printers is that while the materials are significantly more expensive per kilogram of printing, it's also significantly faster. They just had a breakthrough for being able to for making the printing materials focus. I mean, the light focus, so that way it can actually cure the layer at a much faster rate. Just for comparison of what we're talking about things, this is a resin print. Where I got this from, My Mini Factory, there's one of their subsections on there is a number of museums got together and 3D scanned their sculptures, their busts, a lot of their 3D art, and then they put them out there for people like us to go through and print them afterwards. The thing, and as you can see with the resin, for something like this, you can see that level of detail right there. It's really hard to get that level of detail with a filament printer for that scale. This is why you typically use these things for minifigs. On the flip side, when you do larger prints, something you do have to be aware of is these larger ones. You have to hollow them out, or else physical because it's literally the equivalent of school glue stick level attackiness for adhering to the build plate. And when it lights up, it technically creates a temporary connection to the bottom of that print thing. So every time it pulls up, you're literally unsticking from the bottom. And if this is solid, it's a huge layer that it has to pull apart all at once. And therefore it will sometimes come unstuck, stick to the bottom, and completely ruin anything that you're going to print, to a point where sometimes you even have to go replace that clear plastic sheet at the bottom. This one, just for comparison, took 8 hours to print. My alternative comparison is this beauty right here. This I printed on the filament printer, and as you can see, it is much bigger. This took about 2.5 days, closer to 3, to print. Part of it also, though, advantage with filament is that if you're going to do a larger display, it is a lot easier to go make changes to the internals of the print, so that way it will go and be a lot more resilient of a print. In this case, for example, I changed it so that way between my hands here, this lower 20%-ish actually is significantly denser infilled. So that way, if you happen to knock it, you can see it's more inclined to just bounce straight back to where it was, instead of being a lot more top heavy. And what I mean by infill, this was a print that was in progress earlier and failed this morning. But as you can see, it's not honeycomb, but it's the same kind of concept. And you can choose honeycomb for filling it in. It's the joys of printing these things. You figure out what works best for your needs as you go along. Printing is as much of an art as a industry kind of thing. But anyways, part of what I had to do with this also, for when I talk about supporting things, filament can only build out so far before it will just droop by itself, because you're dealing with hot plastic. So what you do, let's see if I can pop this in a hurry. There we are. This is sacrificial material. It doesn't matter as much. But what I did is, for this lower part right here, is I've added support for the thing, and the slicer adds this in automatically. So but then when you're done with printing, all you have to do is break this form of material off. There's also things you can do at the base to help reduce warping, things like that. But in the end, you end up with a product like this once you take all the supports off. And I mean, yes, I did like a 95% job on cleaning this up. There's still little occasional strings on here. This is meant to be just a shelf decoration for me. And that's also the beauty of 3D printing. You can print whatever takes your fancy, and there are tons of free resources out there. Getting into talking about what I mean by a slicer. I'm going to share my screen again. This program here is called Cura. It's put out by Ultimaker, which they also produce their own line of 3D printers. the perk of 3D printing is another perk of it is for when you get into doing things like designing your own prints and slicing them. There is software out there where you can do everything you could ever dream of for designing everything for free. There is no extra cost involved beyond what you put in for your hardware and the materials that you use. Well, I just realized I forgot something for talking about the resin printer, but I'll go back to that in a moment. Basically, as you can see here, this is that same mug that I was printing. This is actually a preview. This is a demonstration model of what I'm donating for the food fight that's coming up. But as you can see, you can look at it on a layer by layer basis to go and see how well things are going to be supported. So that way it's it's a lot easier to troubleshoot for if something actually goes wrong. Like, for example, if I set the infill too thin, I can see, oh, I've got a big wide area at the bottom, and it's going to be uneven because there's not enough support, and then turn it up for that one area. When you get into resin printing, your needs and demands of supporting things change. With resin printing, it's a lot more. I only need points for everything to connect the lowest thing, because as long as everything kind of goes to individual points, you can go and kind of do a spider web of support around it and support it. With something like this, you pretty much have to do a cylinder of support going up to it. Stopping my screen share again and coming back to me sharing things a little bit more. Resin, this bottle was, I want to say that this is another thing about printing is everything's in metric. Since it's a worldwide thing, my printer's technically from China, for example. And in a lot of ways, it makes things a lot easier. The only time you really need to convert to imperial American measurements is if you need to deal with hardware mountings. And with that, you just use a calculator. But anyways, resin has to come in a sunproof, so to speak, bottle. You can I don't know if the mic will pick it up, but you can tell that there's liquid in here, and this is what you just pour in. For processing when it comes out, you have part of with UV printing is when it comes out, it is tacky, it's wet, there's leftover resin on the thing. What you do is you have to wash the print off and then cure it. Curing is just something as simple as getting a bucket, lining the inside with UV lights. I'm not going to turn it on because cameras don't seem to like the glow for looking at UV prints for when I'm showing off things. And then just literally put a paper towel at the bottom. This right here is called an exposure chart, just showing it, just in case you're curious. What it is that these things tell you how well the different UV exposure times your resin will take for printing. That way, it's easier to tune to make sure that you're getting your most optimal print. Filament printing has something similar. This was about I want to say maybe somewhere in the $15 range for this much. The filament, the one that's on the reel here, I bought in bulk, which got my price down to about $8 a roll, maybe $9 a roll. Your fancier filaments, like the ones that will pretty much come out smooth to the touch around the sides of it, those will be a lot closer to $20 a roll. It all depends on what you want to invest in it. The other thing with filament is that there's multiple types, like I know I've alluded to. What I'm printing with right here is PLA. It is the bare bottom, simplest to work with. But there's ABS, TPU, nylon. Nylon is one of the materials that they use for when they make arrowheads for the safety threaded, the safety arrowheads now for Amped Guard, moving away from the old-fashioned washer and washer with a screw in it method. The comparison that I've seen done is someone, and I am completely blanking on who did it, did a demonstration video where they shot unpadded but into a hard foam hunting target, the washer and arrow set, the washer and screw setup into the thing, and by the second shot, not only had the washer deformed, but the arrow was starting to break. And then he took the nylon one and shot it like 3 or 4 different times straight into that same target, and nothing wrong with it whatsoever. He could just keep shooting with it. No deformations, no wear on the arrow, that kind of stuff. There's still some proving for what it takes to get a solid print on that stuff, but that's the future of it. When it comes to hardware for cleaning things up, tools of the trade, the number one thing you will always need is a spatula. Like with the prints that come off, sometimes you need to be able to get under them to flip them off. Also, get a good set of pliers. When you're peeling off supports, sometimes it's just nicer on you and on your hands to just break it off. The other bit also is get some wire nipper kinds of things, because this is plastic, it will clip right off. Also, good set of X-Acto knives. This came with a startup kit that I bought on Amazon, that hence the Chinesium on it. But then also your screwdrivers, socket wrenches, some brushes for cleaning, like for example, around the nozzle, sometimes you'll get spare wax filled up. It happens, just take a brush and brush it right off. The basics for keeping it clean. I'm still learning some of the stuff for post-processing, so I don't really have much to give for that right now. Another thing that's, by the way, that's nice, but mine's a bit excessive. Get a heat gun. A hair dryer will do just fine, because sometimes what happens is when you're printing, your settings will be just a little bit off, and you'll get, for those who have worked with glue guns, you'll get that that long, thin wisp spider silk of string that hitting it with a glue gun actually makes it clump up, so that way you can go in with a knife much easier and just clip it right off. For when you're dealing with resin, I cannot understate how important it is to use that air purifier, because resin fumes you have to go and get out of the air. They also recommend wearing a mask, always, just so that way it's just respiratory, discourage anything from actually going into the thing. Another interesting one, safety glasses, especially for if you decide to get into where if you get a Dremel or some kind of rotary tool, because it will throw dust up, it will throw little spare bits of plastic up. I'm not going to grab it, but I have an apron to help me with that. But anything to keep it out of your eyes, and just remember to keep your mouth shut when you're using that. Works like a charm. I think I've covered everything of that. Going back to going back to things here. Let's see here. Resharing my screen for bringing it back into the presentation. Places to get things. Like I've said, if you know where to look, the start of things is always free. And until you get into designing things, sometimes you'll want to go and, yes, occasionally pay for things like my Hero Forge. Designing your figurines on the site is free, but then it costs money to either have them print it, paint it, and send it to you, or for a little bit less, they will sell you the file rights for your personal use for the figurine, and then you can print it yourself. My personal favorites, though, for items, starting from the bottom, actually, on this one, the 3D Benchy. I don't have one handy. I don't think. Hang on 2 seconds. As I look behind me. Sunday. Here. Another thing about filaments, moisture is your enemy. You want to keep everything as dry as possible, especially for storage. So what I have here is I just took a storage box. You see I've got blue filament here. I've got fluorescent yellow, green, a whole bunch of things like that. And what I've done is there it is. What I did is I put them all in there, and then anytime that I buy shoes or anything that comes with a desiccant packet built into it, I just drop the desiccant packet inside to help keep the moisture out. At some point, I know I have to clean out all the old ones. And also I know that they go and sell, they sell the like oven resettable ones. I'm going to change my screen share just so I can, actually, I'll leave the screen share like that. But anyways, getting back to things for what's on the screen, the 3D Benchy, I'm going to take a moment, put it back to me here. This is a Benchy. The concept for the Benchy, and there are multiple different designs out there. This one in particular is designed to where you take the file, print it as is, and then every single aspect on it is intentionally calibrated, so that way you can go through with calipers and measure to make sure that everything came out the way it's supposed to be. This is made to be printed without supports, and it's a very easy stress test to make sure that you have your printer set up right. The arch, for example, in here, you shouldn't really see too much in the way of loose flopping over filament because of stretching the limits out. The hole in the front here has to be is an exact size. I forget what. I want to say it's 1 millimeter. Does the hole for the smokestack and the one for the flagpole at the back show up appropriately? Do you have essentially square corners for the box at the back? All that kind of stuff. And basically that's one of the best ways to make sure you're calibrated appropriately. Coming back to the presentation, Thingiverse is another one. Everything on it's completely free. It's one of those things where they automatically assume that you have the rights to upload whatever you do. Sometimes you'll see people put things up for Disney self-designed items, and at some point it'll just outright disappear because Disney finally caught up to them and said, no, we have the rights to this, take this down. It happens. My Mini Factory, the reason why I say this for last is they have both free and paid items in there. If you want to get into designing your own minifigurines, settings, specialist items, you can put that up onto My Mini Factory and set it up kind of like Patreon, where people can pay you through My Mini Factory for what you design and put together. It's kind of the best of both worlds. There's a lot of really crazy cool mechanical things on there because people know that they can put it on there and get compensated for their design work, which gives them more money to go and do other design things. And that's the thing about it also with 3D printing. If you see something that someone has done and you print it for yourself, we all operate on, I want to say it's the MIT style license, where it's honor system, but basically we're all promising to not profit off of each other's work. Like I found a phone stand, for example, that I did as Christmas gifts this past Christmas. I had to modify the files to get it to do what I wanted it to do. I'm not going to because I didn't do the base design, I can't turn around and sell those files. If I designed it from the bottom up, that would be different. I could, but it's a level of respect, and it's the root foundation of sharing the hobby. Getting into software, if you there's, like I know I've mentioned before, there are two big items that you can think about. The main one being the slicer. You can't print without a slicer because that's what breaks it into the meaningful layers. I personally use Cura Slicer. Box is tuned for resins. For designing, there's Auto Fusion 360 if you want something simpler. And with no license, there's FreeCAD. There's other ones like that. If you want to get into the fancy stuff, there's Blender. And that's the same thing they used for things like the Disney live action Lion King remake. Exact same software. You just have to go through and tune it to the scales for printing. Getting into the ANS thing, ANS bit of things as I'm in the final end here. What makes a good entry? Looking at the first one is it a solid print? Pulling these two, for example, this is an exploration piece that I'm slowly working on. Real life person. This is just something I pulled off of Thingiverse. I don't know if my camera's showing it up completely, I just realized, but an intact print did the thing print solidly enough where you didn't have to glue things back together? Is anything clearly broken on the print? Is it also consistent print quality? I printed a bust of our King Gaius as an entry, and not enough time to reprint, but I noticed I had one specific area where the filament decided to under extrude on the outer skin, and it's some where it's like, yeah, I really should have gone through and tried to fill it in beforehand, but didn't. That's little bits inconsistent print. Unique print. How common is it for what's being printed? Originality versus changes that make it unique. The Picard figurine that I was showing there, it's not that common, but it's not unique. I didn't do anything to change it for myself. I would personally deduct a little bit based on the fact that there was clearly no effort shown to make it my level of thing. Lastly, level of complexity. A big block of a thing versus a minifig versus a statue. A big bulky block is very simple, and therefore there's nothing really. It's a very simple thing. But minifigurines, because of the level of detail, I would always rate higher. The other bit also is level of resolution. The big Napoleon statue, I turned up the resolution, which is why it took noticeably longer to print. If I had turned it down to the standard resolution, like the feathers would still be there, but some of the intricacies of the feathers would be lost. And so just keeping that in mind. It's also the fact that the longer the print, the more time it has to fail. That's what I'm talking about for things. I mean, getting back into this thing. This is what I'm talking about for when you get into resolution. As you can see, comparable levels of detail, but the resin print is a finer resolution. I would give the better points for that. But the fact that the head ripped open would be a major knockoff for points. The bottom part here, when you hollow it out, when you hollow a resin print out, you have to put drain holes in, so that way any resin that's in the side can come out, or else you will forever have a permanent sloshing sound anytime anyone picks this up. So typically I always ignore the bottom unless there's something very special, specific going on that's drawn attention to it. But then things that also make it unique. Did they take time to paint them? I have not dived into painting prints, so I don't have anything to show for that. But even just a basic, painting like the failed mug here, if I were to just do a basic going around and painting the band around the outside a silver tone to match, to make it look like a metal, that would be more points than just turning in just a straight print. I think I've covered everything that I'm after. So are there any further questions, things to be brought up, concerns?
I have a question. What do you do? I might have asked you this last time. What do you do with all your scraps? Because I've seen people have like taken their scraps and melted them down and made their own filament of it. And I'm like, wow, that's a lot of extra work. Yeah. Is there anything else other than that you can really do with those scraps?
I haven't really gotten into the beyond garbage or recycling yet. Yeah. My bigger failures I make a point of saving for right now. And that's because I do want to get into the whole grind up and recycle prints bit. The thing about it though is the hardware involved is a few $100s. Looking at costs for printing, the resin printer was just a hair under $400, and that's a pretty average sized print plate, mind you. Mm-hmm. The filament printer was just a hair over $300. Yeah. And I know the price has come down. You can get a really entry market filament printer for less than $200.
I know. I was just talking to somebody who got two for $400, just over $400. Like, yeah, I spent like $350 on mine.
Yeah, and it's something where it's right now we're kind of in a boom time for printers where they've gone mainstream to a point where the new developments are coming out to a point where it's like like the classic days for cell phones and computers. There are new models coming out every year, every other year, with newer and more features built and integrated in that do make life easier. Like there's Wi-Fi enabled printers now where I don't even need the Raspberry Pi printer connection anymore. Technically.
I mean, yeah, I was looking at the one, I think it's Snapmaker, that's like, it's a 3D printer, it's a laser printer, it's a CNC machine. You're like, that's really, does it do my taxes? Things.
I have a friend of a friend who has one of those, and it's
order my groceries. Yeah, it's amazing.
It's one of those things where it's amazing, but it's what do you want to invest to make to dive into it? Sure. When you're just starting, it's better to get just the basic printer and then build your setup around it for how you see things go. Don't start with a full big one right off the bat.
Well, I also think that if you're going to get one of the ones that have like the multi-part, like you're going to do like 3 things but not do them well. Like you do things on a very medium scale, but if you just bought them separately, you can do better.
Oh, and something that something that's kind of a general crafting, a general crafting bit. And thank you.
Yeah, I started the craft. Yeah, go ahead.
Yeah, I'm seeing the chat there. Something also for talking about everything in general. Always make sure that you have a dedicated work area for it. The desk I'm on right now is IKEA, and they're still mostly empty, but I have a ton of shelves for hardware, for bolts, for the tools, for everything right here. And it's something where as I do more, I will fill it in and do more. Are there any good resources or people or where to go? There are tons of things on YouTube. I'm slowly building out a website where I'm trying to make it easier to coalesce all these things into one spot. I'd recommend there's a guy, I want to say the YouTube channel is Maker's Muse. He's built out a website, for example, that has calibration specialty stuff built into it. Have I tried playing with a food printer? I know they exist. I don't have the means to get into it. However, I have read an article that someone, I want to say she's in Europe. She got a master's in mechanical engineering, dropped out of the industry when she had kids, found she liked cooking while she had kids, and then basically got into 3D printing, would make these amazing custom molds, build the food into the molds. And so you'd get these imagine creamy little cakes, but because of how the mold is, the layers actually twist as it goes up.
Oh, that's cool.
So it's really amazing designs. Resin, better for award design. Depends on what you want to do. And resin, it's going to be crisper no matter what. But if you're going to do anything bigger, yes, they make resin printers that are much bigger than this, but you're getting into the $700 range. So physically, and if you want to get an equivalent print volume, they make filament ones where you're talking like $500, or even approaching half the cost of some of the larger ones. It all depends on what you want to do, how much effort you want to put into it. Kelly and I have worked together for making awards. I did I printed out, it was a glow moon. It was a moon, half of a moon lamp. Yep. And it's fading into the background. You have to hold up.
All right, there we go. Yeah. So it's, I have, you gave me like 3 or 4 of them.
Yeah.
To do so.
4, so that way if one failed, it'd be easier to do it. The file that I got from someone actually made a full moon globe out of where hollowed it thin, and then made it so that way the printer, you just print it in place for the whole globe.
I have one. Hang on. I don't think it's.
Yeah.
It doesn't work though.
And where it's actually made to be, the layers are made to be thin enough, front to back, so that way it will actually glow through, and you'll actually see all the mountains and valleys as part of it. It all depends on what you want to do. Cheaper to buy in bulk, especially for filament. Yes, there's a company down in Miami, for example. They have one office in Miami. They're international. Where it's cheap filament is what I'm using for the thing. But if you buy 10 rolls of filament, it's $8-9 a roll. If you go onto Amazon, you're typically the lowest you can go for buying in bulk would be like 5 rolls for $12 a roll. And part of the perk for buying from the company, which by the way, part of why I'm creating the list, companies would really like it if you buy directly from them. Yes, you're having to go through UPS, FedEx for taking longer to ship sometimes, but Amazon no longer gets the profit cut of what they sell. And that's part of why I'm slowly building out the website. It's going to be part of it's going to be a catalog of buying all these materials.
Let's see. I don't know if I can turn off your spotlight. Anyway, I got of myself Hero Forge. Yeah, it's ridiculously expensive. Don't buy one of them. I want to like buy the STL and then get it printed out like large. That's fun. Anyway, I'm just showing you my stuff I got. Okay, continue talking.
But yeah, chainmail. There's plenty of discussions out there for people designing more and more intricate weaves, such that they you actually come down to the question of how good is the plastic. Granted, it will never hold up for anything combat like we do, even at our level. However, for doing court armor, court garb and things like that, you can do some amazing things, and that's stuff that I want to get into.
Yeah, like that cup holder. That's perfect for amp guard, because you can just throw that on your, have it clipped to your belt, and as long as you sit on
stuff
it,
like that. Yeah,
great. Yeah.
Also, another advantage for 3D printing is you can use it to make tools to do other things. I don't have any examples on me, but colleague of ours out in the Midwest, he was supposed to be knighted, but COVID. Kerry Miller, I'm blanking on his amp guard name. Millercraft, if you want to look it up. He makes leather tool racks that he sells, and he just put up a picture where a professional company that makes saddles bought a bunch of his things for holding their tooling kits for on their workbench. Yeah, circlets. I'm blanking on her name, but someone that a colleague of ours out in I want to say closer to Texas. One of her squires 3D printed her a circlet.
That's cool.
For things, and she got really bummed when one of the arms of the circlet snapped, and she had to go super glue it back together to hold it in place. But anyways, we are at time. It's 11:50 right now.
All right. Well, thank you very much for your class. I really appreciate it. I'm going to stop live streaming, sorry. And I'm going to stop